Hello and welcome to the White Label series. Today we talk about the concept of a finite state machine, and how we use it in our white label platform. But, let me start with a why. When a vendor enters the data about a client and the requirements for their app, and saves, all we have is some data in the central database. It is a description of a desired state. But, none of it exists yet. It is a process to get from nothing to a fully working app, consisting of many tasks. And some of them cannot start before others successfully finish. And any of these tasks can fail. And, maybe, it will succeed a bit later. Or not. Or, what happens if the vendor spotted a problem and chooses a different set of options, before the first desired state was achieved? Remember this question, we'll solve it first. Obviously, we chose to deal with these issues using the concept of a finite state machine, FSM in short. But, what is it? It is an abstract machine. With a finite number of states. And well-defined transitions between them. Okay, what we want is that the actual app works as the vendor defined it. This is the first state. And the state we want our system to be in, most of the time. But the vendor changes something in the definition. Now the actual app does not work as defined. We need a new transition. Let's call it applying settings. There are huge differences between these two transitions. Changing settings happens when the user hits save, and the new settings are saved, which means that the transition happened, or are rejected, which means that nothing happened. Breaking things is always simple and quick. And bad vendor broke this equality. Now we have to restore it, and that process, as we discussed, has many steps and takes time. But, remember our second problem, changing the definition before the old definition was applied? Well, look at the diagram. Changing settings is only possible in the top state. In the bottom state, no user input should be possible. There are more complex solutions for this problem. Some of them can be reached by using more complex finite state machines. But, I like to keep it stupidly simple. Okay, and our first problem, processes, tasks and stuff? Well, all of it is in applying settings, right? So, we define a new machine. Wait, it is the same one, just the font is smaller, you say, and you are right. We still want to get from inequality to equality. We just need more steps. It is important to understand that either we achieve equality or we don't. In all other states, except the top one, the user cannot change anything. There is one special state, called error here. When this state is reached, the new definition will not get applied, and the vendor will not be able to change anything. What happens here is that we, the developers, get a notification. We can then investigate, find and, hopefully, solve the problem, so this state is never reached again for the same reason. Oh, it will be reached again for another, there is always one more bug in any system. And we can then fake a transition to one of the other states, most probably the bottom one, in order for the process to complete ending in the top state. To make things really simple, one can try to have the same steps and transitions all the time. It does not work every time, well, it could, but does not make sense sometimes. The first transition, from definition changed to database ready. How would you define it? Create database, works only the first time, but, create database if it does not exist, works every time. Remember, the states are important, it is irrelevant how you got into one, as long as you are in it. Okay. Let's talk about the actual implementation. We use Django web framework for our white label control panel. Django is one of the very few frameworks with great libraries for just about anything, and finite state machine is no exception. The one we use is called Django FSM. We added an FSM field with only these three states. There is absolutely no need to have intermediary states in the database, in our case. It is visible, but never editable. When the instance definition is saved, the transition kicks in. In the background, the syncing task is scheduled. This will be explained in our next video. And the field transitions to the new state. Note that all fields are now ready only. When the syncing task is finished, the user will be notified, and the state will return to deployed as defined. And the instance definition is editable again. And in the extraordinary case when the syncing fails, the instance enters the error state, and the interface is not editable. Well, this process is not optimal, as the transition happens also when the instance was saved without any changes. But, premature optimization is the root of all evil. Here is the whole while label series, if you want to learn about other technical topics. In the next video, we'll talk about task scheduling and background workers. You may also be interested in my open source for end users series. Here is the link to my tech channel, and over there to music metadata channel. Subscribe and keep watching.